All right, so I'm starting to question here this 7. And the reason is quite honestly, I was questioning it, so I typed it into my calculator, and that indicated to me that I should not be getting these 7s in the denominators. So I have made a mistake someplace, and I bet maybe there's a chance that you even saw it and wondered what I was doing. And it was very easy for me to spot once I went back and looked at it. Negative 0.4, positive 0.5 turned into negative 4, negative 5. So this should have been positive 5, which let's see if we can follow it through. This would have become negative 3, which means these denominators all should be 3s, not 7. Oh, positive 3. Positive 3. Negative 2, positive 5, positive 3. So these should have been positives. I wonder if I can just do this here. Positive 3s. Positive 5/3, 10/3. Positive 10/3, 20/3. Positive 20/3. Okay, I wonder if I can only fix one matrix here. Okay, so I'm going to cross this one out, and I'm going to rewrite it. It's getting a bit messy for me to follow my work. I know that the left side won't change here. The right side is what's going to change, because when I add row 4 to row 1, 5, 0, 5/3, 10/3. When I add row 4 to row 2, 0, 5, 5/3, 10/3. Row 3 would be 0, 0, 5 plus 10/3. So it's 15/3 plus 10/3, 25/3, and 20/3. And the bottom row doesn't change. Okay, getting a bit messy here, but we got one more step, and that's to do 1/4 row 1, 1/3 row 2, 1/4 row 3. And we're going to put all of those in one step, because changing row 1 doesn't affect row 2. Doing 1/4 row 1 doesn't change the other rows. So when we're done, we get the left side, we have the identity. Oftentimes I go ahead and I put that down first, because I know that the move that I made will turn these into 1s. I'm confident about that. But the right side, we need to be a little more careful. So 5 times 1/4 is 5/4. Excuse me, 5/4. 0 times 1/4 is 0. 5/3 times 1/4 is 5/12. 10/3 times 1/4 is 10/12. 0 times 1/3 is 0. 5 times 1/3 is 5/3. 5/3 times 1/3 is 5/9. Remember, you're multiplying the top numbers and you're multiplying the bottom numbers. The numerators with the numerators, the denominators with the denominators. 10/3 times 1/3 is 10/9. So we get 0, 0 here. 25/3 times 1/4 is 25/12. 20/3 times 1/4 is 20/12. And the last row we are not changing at all, so 0, 0, 5/3, and 10/3. All right, checking here. Looks good to me. Okay, so we are going to now, we have our I minus A inverse. And we need to multiply it by D. I'm looking here. When it comes to multiplying, we're going to be multiplying rows by columns. That it'll be the row of this matrix, like these here, that get multiplied. And right now, they have different denominators. So either I want to reduce them all to the same denominator, or scale up that 5/4 so that it also has a 12 in the denominator. And the 5/12, that doesn't reduce at all. So as I write my matrix, I'm going to give them all 12s in the denominator. So that's 15/12, 0, 5/12, 10/12. The second row, 5/3, 5/9. 5/9 won't reduce, 10/9 won't reduce. So I'm going to make my 5/3 come into a 9th. So that's 15/9. The advantage, again, is that we're going to have to multiply the row times the column, and then you add them. And in order to add them, they must have common denominators. So I'm just taking care of that now. 25/12 doesn't reduce, so I'm going to leave it 25/12 and 20/12. And then I'm going to leave this 5/3 and 10/3. I'm also taking this moment to rewrite my fractions, rewrite my matrix a little bit clearer so that I have more confidence when I go to multiply. So let's see here. Do we want to multiply by 5, 40, 20, 100? Or, sorry, 50, 40, 20, 100. Or those numbers are all divisible by 10. I'm going to take that 10 and I'm going to move it out front. This will give us the same answer. It just makes the mental arithmetic a little bit easier to handle, in my opinion. And there are people that disagree with me, and that's fine. But I know what my mind can handle, and I like the smaller numbers. So because these all have 12s in the denominator, we're going to ignore that momentarily. 15 times 5 is 75, plus 0, plus 10, plus 100. And that's all over the 12th. The next entry, 0 times 5 is 0, 15 times 4 is 60, 5 times 2 is 10, 10 times 10, 100. All over 9. The next row, 0 times 5, 0, 0 times 4, 0. 25 times 2 is 50. 20 times 10, 200. All over 12. Last row, 0 times 5 is 0, 0 times 4 is 0. 5 times 2 is 10, and 10 times 10 is 100. All divided by 3. So it's 10 times 75, 85, 185 over 12. 60, was this a 10? 70, 170 over 9. 250 over 12, and 110 over 3. Now the question becomes, can these reduce? What do we do with the 10? Things like that. And the answer is you can reduce if you can. It's not necessarily the most important thing to do, especially do they reduce? I don't think they do. Not nicely, at least. So let's put that 10 back in. Let's multiply all those numbers by 10. And we end up with 1850 over 12, 1700 over 9, 2500 over 12, and 1100 over 3. Now those themselves would now reduce because the 10 can reduce the 12, the 12 and the 12. The 9 and the 3 cannot reduce. But I'm going to leave it like this because there is an advantage to having those zeros at the end. This would be your production schedule X.